Hi guys, welcome to another Learning Electronics Repair video. This video is sponsored by PCBWay and we're going to build another one of the shared projects today, which is the RF signal generator. I don't have an RF signal generator, so this will definitely add something useful to my test equipment. I thought this might come in useful to myself when repairing radio microphones, because I do get these coming in from bars and places not working, and often I don't know whether the problem is the transmitter or the receiver. So I'm hoping this project will help me with that sort of repair. It's an inexpensive project. I'll give all the details in the description of this video. I'll link to all the various components. Most of them are standard, but the few things you might want to buy, I did buy some parts for this project, but I suspect it didn't cost me anything more than €20, maybe less than that. So let's have a look at the project and then let's see what we have. We'll put all the parts together and we will build it and we'll test it and see how well it works. But first, just a little bit of news about PCBWay, who have some new special offers I just wanted to mention to you. So here we have the PCBWay website, which has many things on there, many interesting things, but in particular to me the shared project section, where you can upload your own projects, you can download projects made by other people, and everybody who uploads gets commission, so you get a little bit of money for your work if you make your own projects and put them on here. And the good news is that now some of the PCBs will actually cost you less money. So we have this news. This is some new information from earlier this month. And PCBWay have now moved to a new factory. Everything is set up properly now. They've got a higher production capacity and they can offer you some great deals. So now 4-layer and 6-layer PCBs are 20% discount. And also you will notice that from 1-layer PCBs, if you design your PCB within these constraints, then you also get a big discount. So there hasn't been a better time really to buy your PCBs. The project I want to build today is this one. So it's a 10 kHz to 255 MHz signal generator with OLED display. It's based on an Arduino. There's a link here which will take you to the sketch which you need to upload into the Arduino. I've already downloaded it and I will put it onto the Discord server at Learning Electronics Repair in case you have any problems. Get it from here. This download website is all in Turkish language. The author of this is Turkish, as you can see, so you may find it easier to just get this from the Learning Electronics Repair Discord. It'll be there for you. I'll just mention that one of the comments on this project, this guy Caesar Sound, is actually the author of the code, the software. And I'm just mentioning that fact. He's asking the guy who posted this to give him credit where credit is due. This guy wrote the software, so I just wanted to make that clear. We have here a small schematic, pictures of the PCB which I have, and just some little pictures showing it under test. The schematic isn't particularly clear, so I did a Google search for the project and I found it on the Arduino website, the original project. Again, I'll put the link for you guys in the description to this video. This is the actual project, and here it gives us a list of the parts we need. So the parts I had to buy were the Arduino Nano, the rotary encoders I have, this module, the Adafruit, whichever you like to call it, the 2 modules I had to buy, the display and the clock generator. We have switches. I have switches, that's okay. I'm sure I can find an RCA jack, some standard value capacitors and resistors. The inductor I had to buy. Here is some information about the project so we can see what we are building. Variable frequency oscillator. It gives a few suggested uses for it. Frequency range 10 kHz to 225 MHz, which I think will be quite useful to me. Tuning steps and a few other things. It has 20 presets, which could be handy. And you can see if you just look down at the various options here. Use a simple RF clock generator for calibration or clock generation, and so on. There's also an update in June where this is being changed to support a larger display. I actually have the original version here, but that's something we could have a look at. It also mentions that there's a bar graph for signal meter. There's an output rather for the bar graph, which I don't actually have a signal meter, but again, that's something we can have a look at. So let's get the parts together that we need on the bench, and then we can start to construct the project. I have the required parts here. The switches are new ones. They're not single pole, double throw. They're double pole, but we can use them. They're also center off, but they what I have, but we can just use them in the up and down position. I mean, they should work, so we have two of those. Here's a rotary encoder with push switch. Yeah, I bought maybe 10 of these in the pack. I needed one for a repair on a car radio, I think it was, so I just bought a few. I'm hoping that's the right layout, that it'll fit the PCB, but I'm sure we can modify it to do so if it doesn't. These are the 100 nanofarad capacitors. They look like the ones in the picture on the parts list. They are poles, so we will test these with the capacitance meter to make sure they're okay. These are the 10 nanofarads. I didn't have that type. I had some of this type, which again are poles, but we can just make sure they're okay. And hopefully that type will work. We have a 10 microfarad 25 volt capacitor here. It didn't mention the voltage on the parts list, it just said 10 microfarad, but I'm guessing we can work out that from the power supply voltage, and I haven't actually checked at the moment to see what power supply this generator needs. That's something else we'll need to work out. So again, that's a pull, so we can test that. We have a 1k resistor, a new one, and this is the 100 microhenry inductor. I had to buy some. Again, I got a pack of 10 because they were very cheap. I haven't tested them. I don't have an inductance meter, but I do have an ESR meter. In fact, no, I tell a lie, I do have an inductance meter on my little €7 component tester. So let's try that to test it. But I'll also show you how to measure an inductor using an ESR meter in case you don't have an inductance meter to hand. It's quite simple to do using an ESR meter, so we can do that. So that's all the parts we need apart from the modules. Let's have a look at those. So this is the Arduino Nano, I believe it is. It comes as a little kit, so it looks like we have to solder the headers onto it. But it looks like it doesn't want to open, even though I just hoped it would. Let's persuade this to open up for us. So there's the Arduino. We've just got to solder the header pins onto it. That's not a problem. Of course, we have to program it. It's a long time since I've programmed any Arduino, so we can have a bit of fun doing that. This is the display module. Again, I will mention there's apparently a modification for this with a larger display, and perhaps we could look at that modification if we like the thing, if it's working well. But this is the little display. Again, came from AliExpress, the same as a lot of these parts. All these parts I have here came from AliExpress, and it was not very expensive at all. €2 or €3, something like that with postage. And the last module was the clock generator. Had a bit of a problem with this one because I thought the number of it started S1 and it starts SI. It's not very clear, you can't tell the difference between the I and the 1. So I was looking for the S15351 and couldn't find it, and it's an SI. Yeah, SI 5351. 8 kilohertz to 160 megahertz. So that goes 160 megahertz, but this generator goes to 225 megahertz. That's interesting. So again, we have to solder a few connectors onto that. and be ready to go. I think the best way to put this together is to fix the small components to the PCB first, then we'll assemble the modules and we will attach the modules, but I'll look at programming this before I attach it to the main PCB. Okay, so that's what we have. The only thing left really is the PCB. So these came from PCBWay. You get a pack of 5 for €5, which is about the same as $5 plus the shipping. So I have a few of them. They look quite simple. So we have the Arduino Nano module fits here, the clock gen module goes here, the OLED here, and then the only thing I don't have with this, and there are mentioned a few things now. If you look at the schematic, there's 2 1K resistors. There's also a power LED. So there's another 1K resistor. So you have to get a few more little bits together. Band gen. Is this the? I don't know. This is where the switches go. Oh, this is the encoder. That's fairly simple to work out. Let's see if our encoder will fit this. Yes, it looks like our encoder will fit this. That's handy. So we're going to have a look at a few of these things that are marked on here that we don't have. There's also a diode marked. Maybe I just didn't look at the whole thing when I was looking at the parts list. Let's have a quick look. No, in fact I did look at the complete parts list, and it seems that our PCB has a few other components, but these look like they're marked on the PCB, so hopefully it won't be too difficult to put this together. Let's start and then we'll just have to work it out as we go. There's a schematic here. Oh, this is a little bit clearer maybe. Yeah, we can see where the switches go now. There seem to be some variations between this and the PCB we have, but I'm fairly confident we'll get there in the end. Okay, let's start putting bits onto our board. I had a closer look at the PCB. So for this we needed 1N4007, which is a rectifier diode. I have one of those. There are 2 47 microfarad 50 volt capacitors, of which again I found some salvage ones. We can test them before we use them. We need 2 more 1K resistors. So there's 1, 2, 3 marked on the board, so I have 2 more of those. It's a 12 volt input, so we can attach something to this. I probably won't put a jack, just to go to the enclosure with a little power supply, I would think. The 10 microfarad capacitor, actually 16 volt would do, but I'm going to quite happily put the 25 volt one in there. It's not a problem. There's something that goes to here, suggests it's probably some sort of switch. There's an on-off switch here. I'm not totally sure where these single pole double throw switches go, because this appears to be just an on-off, and this, well, there's 2 tracks together, so it just shorts together. If that is a switch, it's just an on-off. S meter and TX pin. Well, TX is transmit. Oh, this is your signal meter, which we don't have at the moment, but we can sort something out. So it looks like I may not have everything here to do this, but let's start putting it together. I think there's going to be a little bit of working out as we go along, but hey, that's what this is all about. Yeah, let's see what we can do with it. The reason this has some extra components, basically it has a power LED, which isn't on the schematic which I had. The extra capacitors here, because it actually has a voltage regulator on the back, an LM7808. So this is a positive voltage regulator. The large pad will be ground in and out. So this is where these capacitors go. That's normal. The bottom side, actually, if you follow the track around, comes to the pad, which is ground. This is where your connector feeds the 12 volts in. And if you look, actually, you can see the 12 volts goes up to here through the 1N4007. So this is purely there to ensure you don't put the voltage polarity the wrong way. It goes through there, through the on-off switch. And then you can see from the on-off switch, it actually goes to the input of the voltage regulator. It also has across here, if you look from the 12 volts in, this is ground, this is a capacitor, 100 nanofarads, so that's what the extra parts are really doing. Now, the LM7808 was not on the parts list, so I didn't order any. I don't have any. But what I'm going to do for now is I'm actually going to feed 8 volts into this from my bench power supply initially, so effectively doing what that should do. I'll probably have to feed slightly more because there'll be a 0.5 volts roughly drop across the diode here, but I can use my meter and make sure I have 8 volt supply. Now 8 volts seems a bit of a strange supply voltage. The Arduino Nano goes here, but I had a look at the data sheet and this effectively has its own voltage regulator on. So you can feed 8 volts to this and it will actually drop it down to 5 volts with this little 1117 5 volt regulator, so that's okay. I had a look at the other clock generator. Now according to the data sheet this should have 3 to 5 volts, sorry 3 to 5 volts input, but once again on the unit it actually has a 3.3 volt low dropout voltage regulator, so I'm assuming it will work at the 8 volts, because if we look at the diagram the 8 volts actually goes to here as well. Yes, that's the supply going to here, so we'll try it and see with the 8 volts. I'm assuming the idea is that this regulator can handle more than 5 volts input. I may actually have a look, it does seem a little bit strange, but that's how it is. The other thing that I didn't notice, but it was pointed out on PCBWay's website, that whoever designed this PCB actually got it wrong, and you see the markings here for the little display, OLED display, so it's saying voltage in and ground. If you look at the actual display, it's ground and voltage in, voltage CCC, voltage to the collectors if you like, VCC. So these pins are actually either wrong or they're marked wrong on here. So if you look at the actual connectors on here, you'll see that the N pin goes across here, it also goes down here. This is just a wire link, and this basically, well, it goes to a capacitor here by the looks of it, the positive end. So this is a supply rail, okay. So that N pin, which is marked VN, actually is VN, and the other one ground, which is marked there. If you look at that one, you can see quite clearly it goes to the ground tab on the regulator, so we know that is ground, so we know these are actually reversed. They are the wrong way round, at least for our module anyway. So we'll have to cut a couple of tracks there and wire them the right way, but now we know about it, it shouldn't be too much of a problem. So first of all, let's put the resistors and capacitors on here, and then we'll see what we need to do after that. The resistors I can just fit, the capacitors, because they're poles, we need to test. Actually, I've had a change of heart. I'm going to cut these tracks here first because they're wrong while the board is sitting flat, and then we'll do the resistors. So I'm going to cut this track, which might be a bit difficult to do, and we'll have to just use the resistors meter to make sure it is cut. And then I can obviously wire the ground and power the right way round once I've done this. So there's definitely a few little issues with this project and this PCB, but it doesn't mean we can't build it. Yeah, so let's just make sure we have that. It looks good, and I'll just measure, and then I can easily solder a piece of wire then to where I want to go. Yeah. Same with this one. Again, I think I've cut through the track. It's quite substantial actually on these PCBs. Let's see if we've solved that particular problem. Continuity, it bleeps. So we shouldn't have continuity now from here to here. Yeah, it's okay, it's gone, and we shouldn't have continuity from here to here. Okay, so they definitely cut. Yeah, they definitely cut. That's that one. and this is this one, yeah, so that's okay. Mentioned this before if you're a little bit OCD like me, but it's good practice anyway to put the components with the colour codes all facing in the same direction. Yeah, it goes in. I thought that was going to be a bit tight then. Yeah, it's not going to fit that way. You can see the holes are too close. It's quite likely not a problem with the PCB design. It's just that the guy who did it used the 4 stripe resistor, if you like. This are a little bit smaller than these ones, but there's quite a bit of room on here, so I don't think it's going to be a problem to do it like so. We can get that in there, fair enough. I'm sure I could find some resistors that actually do fit, but never mind. We'll use what we have to hand, yeah. Resistor, resistor. And there's another one somewhere, yeah, it's over here. As usual, these PCBWay boards are very nice to work with, very nice to solder. Yeah, they solder very well. And that looks not too bad. Not too bad. This is my preferred method. Solder them first, chop the legs off, then just retouch them with a soldering iron again afterwards. I find it the easier way to do it. And really this just makes a nice clean edge where you cut it basically. So that's those in. The 100 nanofarad, so we need to test these. They are removed from some scrap items, so let's make sure they are good. I prefer to use the capacitance meter, probably just because I have it. And for electrolytics it's much faster than using the multimeter. Let's see what we've got. 100 nanofarads, good enough. Always do this when you get salvage components, guys. You've no idea if they're good or not. This will save you a lot of time, yeah, and a lot of stress if it turns out you put a short circuit capacitor in without realising it. Okay, probably have to get these legs to straighten up so we can actually use these. Let's see. Do they fit in the board? Actually, not very well. Let's see. Yeah, they do kind of go in, but the legs are a bit thick on them. Because they're just being used, I can see what they're doing effectively. They're just effectively like filter capacitors. They're nothing special. I think I will actually put ceramic capacitors in here. This one might be a little bit more like I should use the one he had in his picture. Actually guys, they wouldn't fit in the board. The holes are very small, so I'm going to put some ceramic capacitors and see if these work. These are new ones, so I'm not so concerned about them being faulty. I'll happily just fit them without measuring them. Yeah, and this is going into the board a lot easier. Try not to stress the legs too much while I do this. So, yeah. I would say they could have made these holes a little bit bigger in the PCB, to be honest. But, you know, if you're using new components, it wouldn't be a problem. It's just I was trying to use some salvage parts. Again, I'll just touch each one, just make it nice and clean. Okay, that's those fitted. We have some 10 nanofarad capacitors as well, the ones marked 103. These are some more salvage parts. Let's see if I can get them into the board. If not, I'll probably have some ceramic ones, but I think these are actually going to fit. Yeah, that one went in quite nicely. And where's the other one? You know, somewhere, yeah, here. Okay. What else do we have? We have the electrolytics. Now I am starting to wonder if these will fit in because there's small holes in the board. Let's see. Always make sure you put these the right way round, and because they're poles, we best to test them first as well. I'm not worried about ESR in this case. These are not high frequency switching circuits, switch modes and buck regulators and such like, so ESR isn't really an issue. I'll just make sure they actually measure enough capacitance. So let's see. Let's see what we have. Good enough. No, they're close enough. While I'm at it, let's check the 10 microfarad as well. Need to get some new meter probes. Yeah. Okay, diode. I hope this will fit. It looks like the holes are a bit bigger actually for the diode, so that should help. Probably not necessary at all actually, because I'm going to build this into its own enclosure, so it won't be using an external power supply. So actually this probably isn't even needed, but still, as soon as I have it, I might as well stick it on there. Because it's going to have its own dedicated power supply in a little enclosure, it won't be possible to put the wrong polarity power onto it basically. Okay, let's do it. Yeah. We have an inductor, 100 microhenries, doesn't matter which way around this goes. Obviously the diode, the stripe was towards the stripe on the PCB. Let's see if we get this inductor to go in here. I'll probably have to bend the legs on this actually a little bit outwards. It's not going to go easily because the spacing of the legs is wrong. Now we have the power LED. We can test this. So the positive goes to here, yeah. Effectively current flows in the direction of the arrow on the diode symbol. So positive to this end, so we can have a look. So if we just put the meter on diode mode, I think it's the longer leg which is the positive. Let's have a look. Yeah, I think you can just see it's lighting up slightly. So we can put our power LED in, like so. And then it's a matter of putting the modules together, I think. Oh, and the wire links too. Yeah, the wire links. Let's fit the modules now. I'll leave this one till last because I need to program it. So we can see this is where the clock generator goes. I have to solder some connectors on it. It doesn't look too difficult. I'm sure I can figure out how they go on. Yeah, like so. So I've soldered the connectors onto this, put the pin header in, and then we can actually fit this. Looks like I need some cables I don't have to properly test this item. Yeah, it's flat. I think probably a little bit of flux will help with this, to be quite honest. Let's see if we can get this thing on. Yep, that's soldered rather nicely. So we'll get the middle pin in now, coming from this direction. Yep. Okay, that looks like it's gone on quite well. Just reheat that one a little bit. So I'll get the other two of these on. We'll get the pin header on, and then I can fit this to the board. I've noticed that these actually solder on the other side as well. I've not used this type of connector before, so we'll once again a bit of flux on this to help it. I'll also put it in the shot where you can see it. That'll help it, yeah. That'll help it. So yeah, we can get these soldered on the back of this as well. Surprising how inexpensive these modules are actually. It means you can build lots and lots of interesting things when you can buy little modules like this cheap. So now we just have to solder the header thing on, as I'm pretty certain we go this way up. We can actually have a look, it should show us. So yeah, VN is at this end. Yeah, so that goes that way up. This should solder pretty well without flux, I think. Soon find out, we can always add a bit. Always add a bit, not a problem. But it looks like it's going quite nicely. I mean, considering your solder actually has flux in anyway, it's rosin core solder. It's also a good job I bought some more because this one's almost done. I have 300 gram rolls to go at, and now I've realised what's happened. So we need to straighten that up. I think the easiest way is probably going to be to kind of lean on it this way and just go across all the pins. Hopefully I'll just be able to actually straighten the whole thing. Let's have a look. Yeah, I felt it go, yeah. See? It's a bit warm to the touch, but it's actually sloped a little bit the other way now. Let's see how it goes in the board. Yeah, it goes quite well. Despite the fact it's sloping slightly the other way, I think we can actually correct that. Yeah. I'll put it a little bit further up, it'll just make it a bit easier. And I've realised now that can't go there because this is in the way. So how do we connect that? I mean, VN is VN, SDA is it's the right way round, but you can't possibly go like that. I think the first thing we should do is refer to the pictures of it, yeah? Well, the reason it doesn't fit is because on the one on the project, it doesn't have these connectors fitted. I just fitted them because he came with it. It looks like the output 0, 1 and 2 come down here anyway, so it's not necessary. This does say VN 3.3 to 5 volts, which worries me a little bit with the 8 volt supply that is on here actually, because there's nothing else on the board to drop the power supply voltage. But anyway, the first thing I need to do is get these connectors back off that I just spent some time carefully soldering them on, yeah. Just the way it is. Should have looked at the picture before, but I'll be honest guys, that never occurred to me, yeah. It just never occurred to me that if this thing came with these things, it must be needed. Okay, let's see how easy they are to desolder. It might be a matter of holding the board in something like a little vice or clamp and then pulling them off, so to speak. Let's try it. So we'll unsolder those. We'll unsolder these. Okay, and then we can flick it over and do the same with the other side. Okay. And then let's see if we can get this to come off. Let's try this, yeah, let's try this. Oh, it's bloody hot. It's very hot anyway. I can hold it, but I don't know if I can actually get these to come off because he soldered both sides. Yeah. Not easily. wasn't the best of plans sticking this on here, and I didn't need to. Okay, that's not going to do it. Looks like I'm going to have to use hot air to get these off. In actual fact, I can't see any other easy way of doing it. And my fingers are now sticking to it. This is why I hate gloves, by the way. Things stick to you and God knows what else happens. Looks like I have to use hot air to get these off. Unless, cunning plan, if I can get this low down enough, these will probably clear over the top of it. Especially if I angle it upwards slightly, that might be the way to do it. Get out of this little mess I've made for myself, yeah. I need to straighten the pins up a little bit more. Still a bit bent. And to do this we have to get some more heat into it. Yeah, I've certainly got them straight. Let's straighten them up. The question is, how low down can I get this? Yeah, let's have a look. Let's have a look. We can get the pins into here, all the way down. Let's see now which way around does this go. So, well, there's a number of pins are marked with names, so we should be able to figure out which way round it goes. Yeah, these are also marked with names as well. So, GL3, 3VT, ground, doesn't go that way around. Does it go this way around? No, does it go this way up? Let's see. Yeah, it goes this way, guys. It's VN ground RST. Yeah, so it goes this way round. Let's see if we can get it close enough down to the board. Okay, that's kind of in there. I can solder it. It's going, it's going, it's going. Right, that's how close to the board it goes. This is cooled off a bit now. Yeah, if I solder this in sort of like up there a little bit, yeah, that'll clear over the top of that. That'll avoid that little issue, to be quite honest. But something to bear in mind if you actually put one of these together, yeah. So we can get away with it. We can get away with it. Just. Yeah, we can get away with it just. So now I need to program the Arduino Nano, and this is where the fun starts. I've not used Arduino for 5-6 years, maybe a bit more than that. So I have the Arduino connected to my computer. It's saying at the bottom here that it's an Arduino Nano on COM7. Now, I couldn't get it to do this originally, and I actually made a separate little video I published yesterday showing how to get my little Arduino board from AliExpress to detect. So I got around that problem. I then tried to compile the software by hitting the upload arrow here. This is the Arduino IDE, by the way. You can download this. Just search for Arduino IDE, download, you'll soon find it, and it's free software. When I tried to compile it, the first thing I found is it was telling me that these includes Rotary.h, and others were missing, well, especially the first one. That's the first one they found was missing. Now, this is something again a bit new to me. Probably a lot of you guys know this anyway, but I'll just mention it. So back in the day, you would have to go and Google. In fact, it gives you the links to find out where these libraries are and then copy them into the appropriate folder. But this is improved since I last used it. So now you can actually just go to Tools and Manage Libraries. Okay. Give it a few seconds while it connects to the internet. And then you can just go into the library manager here and just search or paste the name of the include you're looking for, or I just search for the name of the library without the rest of the URL, put that in there, and it then finds whatever you want to install. So I've actually installed all these various libraries, and now I assume I just compile the program and it will write it to my Arduino. It's compiling the sketch now, it says, and it's telling me that there's a problem. And what it's saying is that the file is too big. Yeah, it's saying that there's not enough storage on the Arduino. Now, this had me puzzled for all of like about 1 minute. And the reason it had me puzzled only for 1 minute is I had a good idea what the problem was. So I'll just show you why I can't actually install the software on this, even though this project was written for this. And that's because when I went to AliExpress, me being a cheapskate, I found the cheapest one I could find, yeah, without realizing it was an 80 mega 168 processor on it. And the 80 mega 168 only has 16k of memory, and I need to use the 328. Simple as that, yeah, simple as that. It's actually telling me on the screen 168 328, and I just didn't look at what I was buying. So I've got pretty much the point where I can't complete this project, but let's talk about a couple other things I can do. I will order the parts I want, and then let's have a look at the second project I want to discuss. This is something I want to build next month, and I'm hoping some of you guys might have some input into what we can build. For a while I've been thinking about building an electronic load. So electronic load, this is in a way a bit like the equivalent of a variable power supply, but it's actually a variable resistance, a variable load. So you can connect these to a power supply, batteries, etc., and you can actually put a load of whatever you want onto that power supply, however many amps you like, and use it to test the power supply, to load test it, or to make sure it actually runs under load. Now, you can buy these things. I mean, for example, this is a dual channel one, 400 watts, so 0 to 20 amps times 2, yeah. And they come in various shapes and sizes, single loads, and you can also buy kits like this, which effectively, if you like, are using an older CPU cooling fan and some MOSFETs. So I was thinking of building one of these. Now, there are some kits like this which are quite fancy, so they give you a display. You can see on the picture here the sort of thing you get with all the various voltage, current, power and so on, yeah. But I think for the instance that I want to use is I just need dummy load, which is quite powerful, of handling quite a lot of current. And if I can just see the voltage and the current, that's all I really need for the point of view of repair work when testing power supplies. So I decided to have a look around to build one of these, and of course I went on to PCBWay into their shared projects and had a look to see what was actually available. And in the PCBWay shared projects I found this one. There was a few others as well, but this one in particular can handle up to 300 watts, and it's fairly simple. So it doesn't have a fancy display, but I have a way of getting around that quite cheaply. What attracted to me this particular project is the fact that it's fairly simple to build, using fairly cheap and easily available components. There's a YouTube video which is actually, the guy is Ukrainian, so credit to this guy from Ukraine. I'm going to order some of the PCBs and give him a little bit of commission, yeah. His design is fairly simple actually. So this is the schematic. I've watched some of the video translated with the closed caption into English. The translation isn't particularly good. I figured out that this quad op amp, which is in one package, 14 pin, It doesn't mention on the schematic what it is. It may say on the PCBs. I can't see from the picture on PCBWay, but I'm pretty sure this is an LM324. It has a 12 volt fixed regulator, 7812, and that comes to here. This switch, I don't read the language, Russian, Ukrainian, but it does look obvious to me that you can either power this from the device you're testing or from a separate power supply, yeah, and that's what that appears to do. This has a variable fan control. This op amp is a dual op amp, 8-pin package, and I'm guessing it's basically the equivalent of an LM324 single voltage rail supply op amp, but a dual package. So I'd have to do a bit of looking, but I'm guessing some of you guys can tell me exactly what that is. Yeah, he mentions in the video, but I think it's a 122 or something. I couldn't really quite, unless the translation was bad. Yeah. Another thing that attracted me to this is that it's a fairly simple design, so that we can probably expand this. I think it's likely you could, by adding more of these output stages, if you like, have a higher capacity one with more heatsinks and go above the 300 watts. I don't really see why you couldn't do that. You could probably make one using 2 PCBs, so you have 8 stages, if you like, all driven from here. We'd have to have a play with it. So effectively using the front end of one of the boards and just this part from the other board, that might be possible. The other thing that attracted me was the fact this seems to be very cheap to build. So the components are standard, Zener diode, couple of NTCs. I might have to get something, another Zener diode. The output transistors it uses, you've got BD139 as the driver, and this D209. Now if we look at the PCBWay project, in fact no, I tell you, if we look at the actual video, yeah, you can see his output transistors are TO3 cans. Looks like he has a driver or some sort of temperature monitor on there as well. I don't understand the language, so I can't really say for certain, but it looks like to me this part D209 you can actually get as a flat pack type package. So these are the BD139 drivers. You get 100 of them for €8, yeah, 100 for €3. So these are going to be very cheap to buy, the driver transistors, just in a pack of 10 or 20. And the output transistors he uses, D209, is probably this one, but in a different package, yeah. I looked at the data sheet for this transistor, and it does appear to be available in TO3 or in this package. So again, we can get these cheap, which makes the units very cheap to build, yeah. And it might well be easier to mount these type of transistors onto the heat sinks. The heat sinks can come from old PC processor heat sinks. And what I have in mind to do is not to build one of these, but to build 3 of them. So I have already some of these. I think I bought these with the intention of building this type of project some time ago, and then never got around to doing these. So these are voltage and amp meters built into one, yeah. So what I would like to do is take some sort of enclosure, build 3 of these power supply loads, variable loads, yeah, as well as the meters, which we have. I have some of these, so these are effectively the resistors you put in parallel with the meter for measuring high currents, yeah, shunts, they call them shunts. So I've got some shunts so we can handle the high current. And on the front of the unit, I'd like to put a socket directly for an ATX power supply from the 24-way, the 8 and the 4-way, and then I'd like to put some effectively banana sockets on there, so we can just use to connect any power supplies. And we have the option then to be able to put loads on 3 voltage rails at once. We can see the voltage from each rail that's coming out of the power supply, so we can make sure it's not dropping under load, and we can see the current load on each. Yeah, I mean, we can expand this if you like and put some temperature meters on it, but what I'd like to do is make something that's going to be cheap to build. The circuit is probably simple enough to build on strip board, Vero board. If you don't want to order PCBs, you could probably build this sort of scratch built. I don't see why not. And it's so cheap to build that we can build a 3-channel active load without spending much money at all. So that's what I have in mind, guys. It's been something I've wanted to do for some time, and to be quite honest, quite a few guys have asked me to do this as well. So let's take that as quite a major project, and let's see if we can make something that really fulfills all the conditions I said. A, it's cheap. B, you can scratch build this if you want to without ordering and paying for PCBs. Yes, I will use PCBs. And 3, it's easy to understand, easy to kind of modify to get it to do what we want to, yeah? If you guys can think of any better way to do it than that fulfills all those requirements, then now's the time to get into the comments below, yeah? But if it's SMD stuff and that, I would probably say it doesn't really meet the requirements to make it easy to be scratch built. But hey, if you guys can give a good reason why we should go down that route instead, why not? Let's have a look at it. Yeah. Okay, so bit of an interesting one, I think. With nothing quite succeeded yet, but I've got parts to order for the RF generator, and we know where we're going, hopefully, with the active load. I'd like to thank PCBWay again for sponsoring this video, for making this possible for me to do this, and I'd like to thank you guys again for watching my channel. Okay guys, see you all soon on another Learning Electronics Repair video. Ciao for now.